Hi, everyone. Welcome to Data Quality Meetup. We are going to give everyone a few more minutes to join before we kick off our first lightning talk. In the meantime, we'll start with our original tradition of you typing, where are you joining us from? And optionally, what is your favorite SQL function that you use at work? Someone's favorite function, Oleg's favorite function is drop. Oleg, I'm glad we're not sharing a data warehouse with you. Oh, by the way, Livestorm has this new feature where you can do emojis, and then those emojis flow through everyone's screen. So yes, like that. That's quite intense. And by the way, a few tips about the platform. When you're watching lightning talks, if you find the sound somewhat distracting, there's a button on the right bottom where you can mute the notifications so you don't get this pops every time someone is posting a message. So a quick note about our logistics today. We are going to hear 4 awesome lightning talks on a variety of topics, ranging from how to create a one data model for your entire organization to observability in machine learning and building high quality streaming machine learning applications to how to structure a data team and how the structure of your data organization and your stakeholder relationships can influence the effectiveness of analytics. So very excited for the lightning talks today. And then we'll transition to a panel discussion, and we'll go through a few questions around the trends, best practices, and challenges that everyone is facing when they're trying to do data better. Awesome, looks like we have quite a global meetup as usual. So thanks everyone for finding time to join us amid the vacation and start of the school season. And we're going to transition to our first talk today. So I'm excited to introduce Ahmed Al-Zamadisi, who is CEO and co-founder of Narrator, also a very experienced data engineer, who will give us a pitch on the best data model that you can use for your organization. So take it away, Ahmed.
Awesome. Just going to share my screen here. Hopefully everyone can see my screen. So I'm Ahmed, co-founder and CEO of Narrator. Prior to this, I led the data team back at WeWork. And prior to that, I was doing AI for missile defense for Raytheon. So I'm here to talk about creating a single source of truth. The first thing I would like to say is that everyone loves a single source of truth. It's kind of the holy grail of data. And every single person probably in this talk has once said, why don't we create a single source of truth? Creating a single source is actually kind of easy. You build data models that all have the data you need, and you point all your visualization, materialization, and everything else you need at the right data model. And that's it. If this was true, the talk would be over. But reality is not so simple. If we take two examples, like your monthly sales data and your marketing visitors to sales data, and you just sum the total number of sales by month, the numbers add up, and that leads to a lot of cascading problems. I'm sure you experienced the angry executive saying, "Hey, numbers don't match," and starts yelling at you. And that could be for many, many reasons. One, you're asking different questions based on the time of the visitor, while the second one is based on time of the sale. Two, there could be a bug in your SQL because these SQL queries get pretty complicated. And three, it's that not every marketing visitor actually has, or not every sale has a marketing visit due to like idea resolution and many, many reasons. And understanding this complication leads to a lot of issues. And that's why we have a solution. What if you actually did create a single source of truth? And by single, I mean a single table. What if we take all our data and put it into one single table where every row is a customer, action, and time, and you would actually create it? The benefit is you get the dream of a single source of truth where it's actually one table. Two, all the numbers will match and it's super easy to build. And three, it's just going to be really, really fast. The downside is that this table is going to be extremely hard to query, but we'll get into that in a second. So the activity schema is what we call a single source of truth table. It's simply time, action, customer, and you can actually build all your materializations, your plots, and everything just by querying the single table only. If you want to learn more about it, we actually open source the schema and write all about the spec in activityschema.com. So getting started with activity schema is really simple. You take all your raw data in your warehouse and you simply map it to these 11 columns. There are usually 20-line SQL snippets that take about 10 to 15 minutes to write, and you can get started by unioning all these transformations into one table that we call the activity stream. So let's think about how to use it. When it comes to using this table, you have to kind of query it a little differently. If you're trying to create that example of every month, how many total website views and total orders and the conversion rate, what you're going to do is go through every single activity that is a website visit and look at that activity and see if someone completed an order after that activity before they visited again the website, like in between. If they did, if the same customer did it, we're going to put a 1. If they didn't, put a 0, and we're going to call this thing did order. Then it's as easy as counting the total number of rows to get how many sessions the customer had, summing up the total, this did order column to get the total orders, and if you average the did order column, you get the conversion rate. It's that easy. The only difference here is that we're joining mostly on time and customer. And we call this relationship of joining this data first in between. And it turns out you can answer so many different questions by using this kind of approach. If you want to know the best email campaign to get your customers to order, you can just look at every opened email first between completed order. If you want to know the best paywall to getting subscribers, all you have to do is start a subscription, get the last before viewed paywall. You want to know how long it takes someone from visiting your site for the first time to becoming a lead, it's going to be first viewed website to first after submitted a lead. And it turns out that almost any question you can come up with can be answered by these 11 relationships. By simply combining these building blocks and using these time-based operators, you can actually create any table you want. And I've been doing this for years. If you ever come to any of my demos, I will take live questions and show you how any question can be assembled with just these simple operators. Now, how do we actually do this first in between? Well, when you go to match data based on customer and time, you're doing a lot of window functions and you have to kind of be very clever, and it ends up becoming really hard to do this in SQL. So to make this a lot easier, we decided to build a system to help you auto-generate these queries. So in our app, you can actually generate these complex queries that are using some window functions and very optimized to combine these building blocks to create the data you need instantly. And putting this all together, we can actually learn a little bit about this value. By just creating a single table, we can actually create a single source of truth. From this one 11-column activity schema table, you're able to simply define your concepts as tiny little SQL snippets. Super easy to write, super easy to debug, no data dictionary needed, no debugging, no dependency manager needed. And then you can run your entire system on top of that activity schema. You can easily combine those activities using time-based operators. It guarantees that all the numbers are going to match. You'll never drop any rows. You can easily add columns by borrowing them from other activities, and the entire relationships that you're using are all human understandable. So not only you can do this as a data engineer or a data analyst, but this can be expanded to your entire organization. And if you want the best results of creating that experience, you can use our automated tool dataset to create these auto-generated queries. Thank you. And if you want to learn more about us, you can check us out on Narrator.ai.
Thanks so much, Ahmed. I remember back at Lyft, I bought so we were redesigning data model, and I bought the very thick and old data modeling book by Kimball, and we were methodically trying to implement a star data model to make it work in a 200-person data org, and that was a very, very big challenge. So I think a lot of problems probably could have been solved by activity schema. Actually, we're using activity schema at Datafold for our product analytics. So that's very exciting. And also looking forward to grilling you on some questions during the panel.
Awesome. Love it.
Thanks so much. So I would like to invite our next lightning talk speaker, Katya Ogai, who is director of data at AppFolio. So Katya, welcome on stage.
Hi.
Awesome. So,
can you hear me?
Yes. So we talked about how the structure of your data can impact the effectiveness of your organization, analytics, and data quality. But what about the structure of people? So Katya will give us an awesome overview of how that impacts the effectiveness of analytics. Take it away, Katya.
Thank you. Let me share my screen. All right. And awesome talk, Ahmed, by the way. I almost forgot what I was going to talk about. Hi, everyone. My name is Katya Ogai, and I will be talking a little bit about leading a thriving, quote-unquote, millennial analytics organization. And the reason I decided to throw in millennial on here is by no means to be exclusive. It's just to highlight that our newish wave of professionals is really seeking fulfillment in our work. We want to feel that it's meaningful, we're about adding value, and we're having vertical and skill set career growth and development. So a little bit about myself. I'm currently director of analytics at AppFolio, supporting investment management product. Prior to that, I was at Twilio and Lending Club. And completely unrelated to the talk, I'm also featuring my COVID dog, Kodak, over here, who's starting to take over my entire life. So how did I start thinking about structuring analytics organization and just really like putting more thought to it is basically through my past experiences I have had and seen a lot of different structures and seen what works and what doesn't. I started at Lending Club and spent there 4.5 years, and I was lucky enough to support sort of like a startup organization within a larger company, and I was the first analyst on that product, so building out the infrastructure ground up, having a lot of control over what metrics and analytics looks like, and was sustainable for the scale and the size of the company at the time. And I think a lot of people might be in the same position where you might be part of a startup and you might think it's too early to be thinking about structuring a larger scale analytics organization, but I believe it's never too early to put a little bit of thought behind how you want to continue developing your org and growing it and being prepared for scale when your organization grows and you have multiple products, multiple regions. Then I went over to Twilio, which is a bit more of a complex business, multiple product lines. It's a worldwide operations business. There's a B2B and B2C funnel flow. So you can imagine there are a lot of different cross sections of how analytics can be done, depending on your region and product. And Twilio was more of a decentralized analytics organization, and I found that it was kind of difficult to balance the pressure from the business stakeholders who are more focused on optimizing for speed and visibility and putting, like the latest, sexiest analytics in front of the execs, and balancing with the spirit of analytics of building for scale and tackling the more foundational work like tech debt. And so with that, alluding to different types of structures out there in our current market, the centralized structure, which is what Lending Club was more like, typically looks like there are analysts that sit directly under the analytics leader, and the department head sort of put in the requests, and those requests get prioritized and handled as resourcing allows. The pros of that are definitely that this is the highest degree of control for analytics. You definitely have full visibility into the metrics and the data that's put out there, and also highest degree of technical mentorship for the analysts. But the drawbacks is that it can feel very bureaucratic from the stakeholder perspective, and for analysts, it's typically harder to build that business subject matter expertise. Next is more of the decentralized view, which is what Twilio was structured as, where each department has their own analytics support. The pros are this is the fastest output for the business, and the highest level of and highest opportunity for building that subject matter expertise. But on the other hand, typically I've seen it being very siloed, both in the perspective of business cross functionality and as well as technical mentorship. Typically, your boss is not someone who's very technical and is going to be able to guide you in your development of your technical skill set. And so that brings me to the third structure, which is what I favor most, and which is where I'm starting to think about as I'm gearing up to build out the analytics org within AppFolio. This is a hybrid structure where the analysts still have a formalized relationship with the analytics org, but there are dotted lines into the departments. And this provides the best of both worlds, really, the technical and business mentorship and support, but also allows the analysts to serve as an independent partner, a thought partner to the business. The one thing to really watch out here is this dual reporting structure can sometimes be a little bit confusing for the analysts, and you just have to make sure that there is a lot of proper visibility for both of your management heads and leaders. And this is definitely something that I'm still building upon. Actually, one other point that I think is important is sort of like this cross-functional focus, where an analyst can have a primary department they support, but then a secondary focus where this allows for higher cross-collaboration opportunities for synergies, both technically, but also supporting the business viewpoints on how to, for example, do cross-funnel analytics. So yeah, these are just some of my thoughts on where I've arrived so far on how to structure a thriving and fulfilling organization, and be happy to chat with anyone if anyone has any further thoughts on this. Thank you. Oops, how do I?
Thanks so much, Katya. That's a very neat walkthrough of different structures. What's interesting is that most organizations tend to evolve how they run analytics over time, and oftentimes start with a centralized approach and then go to decentralized and then try to bring it back under control with a hybrid model. So excited to also hear from other folks on the panel how they do it. So looking forward to diving in deeper into that topic. And for those of you listening in who are hungry for some really technical talks and specifically on data science and machine learning, I'd love to introduce our next speaker, Gilbert Watson, who is senior data scientist at Truebill. Gilbert has brought us a talk that we wanted to hear for a long time. So about building machine learning apps with Apache Beam. Apache Beam has long been this very sort of under-invested Apache project that many people were excited about, but not many people actually got to use or even to read about. So it has a lot of promise in terms of how you can build reliable data applications, either for transformations of data or for machine learning. So super excited to hear Gilbert's and team and Truebill journey on that. Take it away, Gilbert.
Thanks for the intro, Gleb. That was a good introduction. Tough to go third here. Great presentations ahead of me. So this is they're gonna be tough to top. Let me share my screen. So hi, I'm Gilbert. Like Gleb said, I'm a senior data scientist at Truebill, and I'll give you a little introduction to what Truebill is in a second. I'm going to talk to you today about using Apache Beam and cloud Dataflow on Google's cloud to build streaming ML pipelines. I'm going to talk about our observations at Truebill about using these products and talk about how just easy it is. It's super easy. So first, a shameless plug. Truebill, it's the best.
Or you plug, not to cut you off on that one. Can you go full screen so we can see the? Awesome. Okay, yeah, please continue. It was awesome.
Sure.
Everyone download
Everyone download it. Managing money can be hard. Don't do it alone. Truebill empowers you to save more, spend less, see everything, and take back control of your financial life. It's a pretty strong statement. So go check it out now. But moving on to the meat of the talk. I always like to start with the business problem that we wanted to solve by using these two products I want to talk about today. You can't do anything without a motivating business example, or it's pointless to do anything without a motivating business example. So let's start there. So the business problem we had at Truebill is around ad measurement and Apple's new SCAD ad network. What's SCAD ad network or SK ad network? That's Apple's new ad tracking transparency solution. You've definitely seen commercials about this. Apple's been touting it heavily. And it totally changed the way marketing and digital attribution is done. We're not going to get really deep into the technical details today, but I just want to highlight that it has changed everything in marketing. Let's talk about what has changed for Truebill in particular. When we used to do ad measurement before these changes Apple instituted, we had a pretty clean data sets we were able to use to measure how our ads were doing. We had some semi-deterministic ad attribution data. We knew exactly what ads users were seeing before they came onto our web app or onto our apps, and we could match that to exactly what users signed up for our premium product, exactly what users were doing in the app, what screens they were seeing in the app, what type of product interaction they were having. And we could use that data to measure ad effectiveness. What we would do is we'd have all that data in a database, and in batch every 2 hours, we would run an ML model that produced an expectation of LTV. And just backing up for all those that don't have a lot of experience with ad measurement, what's LTV? LTV is user lifetime value. And if you marry that with the cost you pay to run ads, or aka acquire users, then if you have an LTV to CAC ratio greater than 1, you've got great unit economics, you're making money over some time period at least. If it's less than 1, that's not great. You're not going to have a business there, at least in the long run. So just a quick review on that. So this system was working for us, but again, we had very good fine-grained information into exactly which users ads were seeing before they showed up on our site. What changed? Apple removed this link between what ads users were seeing on what platforms and the users that we ultimately acquire and see in our app and in our web properties. Apple still provided a way for us to get aggregate attribution data from ad networks. So for example, we can still know exactly how many installs Facebook drove yesterday. We might know how many installs a particular ad campaign drove, but we can't link that to any single particular user on our side, on Truebill's side, and in the product, and that creates ad measurement problems, right? Because this user level LTV model we had built no longer works. Luckily, Apple provided some additional measurement methods and provided that through SK Ad Network that we've tried to lean into. And we're not going to get super deep into that again. There's a really complicated flow diagram here to the right. If you want to go read more about that, like check out Apple's docs. But the key level points for us and what we need to know about this so that we can understand why we chose to go with Apache Beam and streaming ML pipelines is that we needed to design a system that delivered user level expectations of LTV to the device very quickly so that we could use Apple's measurement schemes. This need for ASCP data back to the device as soon as the user installed or signed up for Truebill didn't work with our batch LTV pipeline. Like if you recall, we were only running our ML pipeline for LTV every 2 hours, and that just didn't work anymore. So we had two possible solutions. We could either design a ML system that's faster and can send LTV expectations to the device relatively quickly, which I'm going to call like there are streaming LTV estimates to device solution, or we could put an LTV model on the device and have the device side code deal with all that. We chose ultimately to go the streaming side because it's a lot easier. We as a company just aren't prepared to do ML ops for the models on device. So that's why we chose that route. So what solution did we come up with? We decided to implement streaming ML pipelines on Apache Beam. And let's like walk through the architecture of what we designed, and then we can talk about why this was a good idea and works for us. So no longer is our source of data for our ML pipelines our feature set. Recall that in our batch pipeline, we had data about where ads came from or where users came from and what type of app interaction they were having. That data comes from Segment now, and Segment's providing us a near real-time data source for this data. It has because of the way we've implemented it, it provides very fine-grained information to what exactly users are doing on our app. And we pump that data directly to a pub subtopic. And then we have an engine that's designed using Apache Beam on top of Google's Dataflow product that reads in all those events and in near real time creates feature sets and creates ML predictions on top of those feature sets. It dumps those predictions and expectations to another pub subtopic, and we deliver those expectations to the user's device via background app push. And that way we can use Apple's measurement solution. So let's talk more about this middle piece, because that's what we're here for today. Why did we go with Apache Beam and Google Cloud Dataflow? Well, Dataflow is, or Google at least, is a heavy supporter of Beam these days. So one of the big reasons to use Beam is portability. It runs on Google's Dataflow product. It runs on Apache Spark. It runs on Flink. And because Google is supporting this project in a major way as of late, Dataflow just seems to have a lot of the best features for many of these runners. But portability is big for us because we can decide to move this to a different cloud on a different runner at any point in the future. It's important for us that Beam was open source. It works with us from a legal perspective. It's a unified framework, so if we ever want to create batch jobs that run on the same infrastructure, we're able to do that too. It's got multi-language support. It's got support for Python, Go, Java, so lots of options there. Most importantly, it's just a really nice abstraction. It's far less code than if you were to write this directly using Flink, the Flink SDK, Flink APIs or SDK. Same with Apache Spark, and that just leads to fewer programming errors. This is a data quality meetup, and I think this is the #1 point: is that less code, fewer programming errors, and that's why we like this for streaming pipelines. And it reduced the need for device side, back-end side development. For example, if we put a model behind like a microservice endpoint or something. So how easy is it? It's super easy, and this is a little bit of a simplification, but I mean, this is like 20 lines that is pretty much the meat of how we do streaming pipelines here at Truebill. So what's happening in here? We're reading in the events from PubSub that are ultimately coming from Segment. We're grouping those by user ID. Again, we still want to produce an expectation at the user level, so this is a key step. We are creating session timeout windows so that we know when we want to go send a expectation of LTV to the user device. We want that to time out after a certain amount of time. In this example, it's 5 minutes. So after no activity for 5 minutes, this pipeline will emit an expectation to the user device for use with this measurement solution. Finally, we map all of these individual events that we get from Segment to a set of features that we're going to use in our ML model. How easy is that? Again, this is a gross oversimplification, but this function you might use, it illustrates how to get like total event count, and we've defined many features in similar ways. Finally, we are going to use a model that we have trained elsewhere but are loading here in this pipeline, and that's very simple as well. Here's a good example. We're using XGBoost right now, XGBoost-based models. We've used lots of other stuff, but that works for us. So how well does it work? It works great. I mean, with a very minimal pipeline, we're like pumping through 200 plus events per second. We're pumping out 60 plus LTV predictions per second with less than like 20, 30 second segment to end device latency. Like this really is working well for us. Could something else that's lower level worked better? Maybe, but we really like it. It's working for us, and the simplicity is a real value add. So with that, I'll send it back to Gleb.
Thanks so much, Gilbert. That's very exciting. I think that for folks who are not familiar with streaming pipelines, let alone streaming learning pipelines, the definition that Gilbert has shown, which fits, into 15 lines of code, it's actually incredibly neat. So I remember us building streaming applications on Flink using the raw Java API back at lib for anomaly detection, and that was far more sophisticated and complex in terms of the code. So super excited for Beam, and looks like it's been really effective at Truebill. Thanks, Gilbert.
Yeah, no, thank you.
Awesome. So our next speaker, who is Emeli CTO and co-founder of Evidently AI, a tool or a platform for proactive data quality management for machine learning applications. I hope that was the correct definition, Emeli. So let me just invite her to the stage. Awesome. So if you visited our previous meetups, you probably heard me talking a lot about proactive data quality and how you can implement data quality processes in the developer process so that we as data engineers and analytics engineers don't break data in the first place. So how can we embed data quality practices inside our workflows? And what we're building at Datafold also helps with that, but that's all concerns the data preparation workflow. So how do we get raw data useful before it gets into BI applications, before it gets into machine learning workflows? And what Emeli and team are working on is very interesting because they built an open source framework that allows data scientists to very easily evaluate the impact of the changes they make on their machine learning code, their feature generation code, on the quality of those machine learning models, as well as to monitor them in production. So I think that's a very, very powerful concept and something that was desperately needed by the data science community. So super excited for the talk. Emeli, take it away.
Thank you so much for such a nice introduction. I'm going to share my screen now. Yeah. Should be working now. So hi everyone again. Happy to meet you there. My name is Emeli and I'm, as Greg told before, CTO at Evidently AI. So at Evidently we build a tool to monitor and analyze machine learning models. And this is why today I'm going to share with you some tools on how data drift can serve us as an early monitoring for machine learning models. So there are a lot of different things that can happen with machine learning models since we put them in production. And in most cases, when something is wrong with the model, that's because the input data is wrong. And there are, frankly, a lot of things that can happen with the input data, starting from the data processing issues, data schema change, especially when we use some external APIs or databases, or the data can be even lost at the source, which once happened to me when there was a physical sensor, temperature sensing broken, but the value that it shows was still in the expected range, and yeah, it was pretty hard to catch it. But yeah, even if the data engineering team had their job done and there is no issues with the data quality and data integrity, there are still some things that we should care about. So first is the concept drift, which is the change in our target function. And this change can be gradual, which is accumulate over the time, or it can be sudden. And the recent pandemic is the perfect example of such changes. Almost over time, a lot of patterns has changed and many machine learning models became irrelevant. And together with concept drift or separately, we can face a data drift. This is the case where we see the changes in the features that we use, and this can happen just because the world is dynamic, right? Many things is changing. And for example, if you have some churn prediction model where you have a lot of users coming from different channel, and once your marketing team run very nice campaign and attract a lot of users, then the distribution of user acquisition channel can change because, for example, instead of a lot of users from paid search, you can face a lot of users from social media, social networks, right? And in this case, model's quality can degrade a bit or heavily, depends, right? So how to account for it? Of course, monitoring. And one can say, okay, but we have a lot of production services for ages. Why should we care about machine learning specifically? The answer is because together with the service health, we should account for data health and model health. And we are pretty convenient with the model health since we have a ground truth because, well, we can estimate a lot of quality metrics based on the comparison of our model's output and the ground truth. But what should we do when there is no ground truth? For example, when we have it with a delay. In this case, I believe we should care a lot about data drift and concept drift because this is the signals that we have, let's say, immediately because, well, since we can generate some models output, it already means that we have some features and then we have this output, right? So we can compare our output with the output we had, for example, at training or on top of our historical data during the experiment phase. And we can compare the distributions of output of input features and see if it meets our expectations or not. And here I dare to share some code. Hopefully you'll enjoy it because, well, I'm going to share how I can create the dashboard using Evidently. It's open source, and I believe for some of you it will be quite interesting and useful. So we are going to play around with the well-known dataset. It's dataset about bike demand prediction, where we have a lot of information about the weather conditions, and we need to predict how many bikes will be taken to rent. So this is the dataset we have. There is an information about temperature, humidity, wind speed, and the target is the count, the amount of bikes which is taken to the rent. So first of all, as all data scientists usually perform some feature engineering to create some interesting features. So let's add information about months, hour, weekday, because it have very strong influence on the amount of rented bikes, right? So that's how our data looks like. And before build the dashboard, we need to perform some labeling. So let's create the target variable, which is account, because we need to tell later evidently where is our target. And let's create a list of numerical features and categorical features. So here it is. Then let's split our data into two parts in order to simulate the two data sets: reference data set where we train our model, and the production data set, the data set from the production stage where we use our model, right? So now we have everything to build the dashboard. So let's do it. Evidently can parse the structure of data frame automatically, but when you have some interesting cases like categorical features encoded by digits, because this is what we do for training machine learning algorithms often, then it makes sense to create the Python object, Python dictionary column mapping, and tell evidently straightforward where you have targets, numerical features, and it will help to parse the data correctly and apply correct statistical tests. So here it is, and now we are ready to create our dashboard. So for doing this, we just call the dashboard object. This is the object we imported earlier from evidently, right there. So to generate the dashboard, we just need to select the tabs we are going to build, which is data drift and numerical target drift in our case, and then just run the calculate method where we pass the reference data set, which is pandas data frame, production data set, and our column mapping. So that's it. It's generated, and in order to see it, we just need to run method show from our dashboard object. So here it is. It's loading because we have a lot of visualization there. So it's pretty convenient because you have all the visualization available in your Jupyter notebook, and that's how it looks like. So our dashboard contains from two parts, data drift and concept drift. So here we can see that 4 out of 6 our numerical features are drifted. So we can open up any of features. For example, let's open the temperature. And you can see that yes, the distributions are different. We can pretty much see it in the preview. And if we open it, you will see that the temperature during the reference period of time was lower, right? And starting from 12th of February, it started to increase, right? This is why actually data drift is detected, as you see from table. And you can move to second tab, which is data distribution, and see that, yeah, distributions are different. And of course, same information is available for all the rest features, so you can open up and see how it looks like. And the second part of the dashboard is target drift, which showing us that the distribution of target function is actually also changed. So the demand for bike is increased for February, which is basically depends on the weather, right? And the weather became better, so more bikes are taken to rent. And this is how you can analyze what is happening with the data. So in case you have the ground truth with the delay, you can calculate the data drift, you can calculate the concept drift for your model's output, and if you see the changes, then this is a pretty straightforward signal that you might experience some problems with model's quality soon, and maybe it's time to intervene. So there are a lot of nice visualization available here. Just come to see what we have in our GitHub. It's open source. And my last observation is that often we're using some prediction pipelines, and it's not that convenient to use HTML reports to analyze the quality. And for these cases, we also have the profile, which is the same report but in JSON format. So for building it, instead of dashboard, you can call the profile method, and it helps to generate the report in a JSON format, so you can easily derive any part of the report, such as p-values for statistical tests, or maybe some information about distributions, and easily integrated into any tools like Emeli or Airflow or other tools you use to automate your machine learning pipelines. So this is basically all I wanted to share with you today, and we'll be happy to answer any questions later on.
Everyone, check out Evidently on GitHub and give them a star. So I'd love to transition to our panel discussion. So I would like to invite all of our speakers back on stage. And we'll be also joined today by Akshat Nair, who is engineering manager at DoorDash. DoorDash is perhaps one of the largest data teams today in the world, definitely in Silicon Valley. So we have speakers who represent different data organizations that are structured differently and have different technologies, different approaches and products. So that's why we love those panels, because we can see how what are the general patterns that are universal across all the teams versus what are things that are applicable at particular stage or type of the business. So the first question I'd like to ask is a follow-up to Ahmed's talk about data models. By the way, Ahmed, could you, let's do a quick outro check. Yeah, I think right now it seems to be good. Awesome. So I feel like structuring data for us as data people is one of the biggest things we think about, because that ultimately influences how the rest of the organization can use it. And many of us have some ideals in our minds of how we should model data. Either it's a star schema approach, the old school, the data vault approach, the activity schema approach, but often it comes down to what actually can work in the reality today with our infrastructure and the team. So I'm curious, what is the data structure or prevailing data modeling approach that you use in your organizations? Katya, Akshat, Gilbert, so really curious how it works for you.
It's interesting. We actually use a combination of both the old school and what Ahmed proposed. So I think like data that comes out of any generic CDP integration, like a segment integration, looks very much like the event style data Ahmed proposed. And we're heavy users of that for analytics purposes. But we're also old school users of a star schema because, well, a star schema runs our production database, and we often have to answer questions about what's going on in there. So we use a combo approach.
Yeah, we also have, I think, pretty much similar approach like what Gilbert said. It's like a combination approach. Definitely, we are evolving more towards using the activity schema kind of things, but for transactional processing and answering a lot of our like financial reporting and things like that, we are using the star schema.
Yeah, it's definitely a combination. I feel like we could probably be a little bit more disciplined around being very like purposeful with it, but I think sometimes you just get caught up in like, I just need it this way and I'm just gonna make it, and it may not fall under like a specific strategy.
Makes sense. Yeah, and what I find also that is, it's very hard to enforce the data modeling structure on the entire organization, because everyone, unless it's a fully centralized org and you actually can control absolutely everything, but then you probably are sacrificing speed. So related to that question about the structure of the org, how have you seen the function of analytics evolve over time in your organizations, and how, in your opinion, from where you are, that impacted the effectiveness and also the ability to deliver data reliably?
So one thing we've been started seeing with a lot of our customers has been a shift from kind of what we call playing catch up and answering requests to being proactive and doing the deep dive. So a lot of our customers will start off, Narrator allows a lot of people to self-serve their own questions with so everyone's in the same single table. And what we see is a lot of the stakeholders are able to actually answer their questions and get analyses on their own, right? We auto-generate analysis for them. They're able to actually make a lot of the first and second order decisions and follow-up questions on their own. And what we saw was that those embedded analysts now started shifting into being thinking about the big questions instead of what's my conversion rate based on how many does calling impact our conversion rate to a sale and when should we call people? They're thinking about what is the right approach to shift demographic or to shift the customer usage to get them to spend more time viewing the FAQ page because of a downstream effect. So by seeing that more proactive view of data analysts, I think what we've seen is that it makes a much bigger impact because it allows those data analysts to use that valuable skill set of asking really good questions.
Yeah, definitely. I think I can agree with that. There's definitely a push and a shift towards data analytics having like a seat at the table where like we're more of thought partners and not so much like request takers. But it's still like a needed layer, right? We're still always going to need to provide like historical reporting on what has happened, but there is, I think, more of a desire from probably like the analytics professionals themselves to be more of the thought leaders, and like because we have a lot of that like large scale understanding of what's happening both beneath the surface, like from the data perspective, but also like how to like make strategic decisions based on what we have. And so I think I can definitely see that shifting, and I'm welcoming it. But I think there might be more of a that decoupling in the future where there's like the reporting, like self-serve analytics build out, and then like the proactive future looking focus.
I can add that we definitely have like the hybrid approach that we talked about in terms of the organization where we have analysts embedded within different teams and there is like a two-way reporting structure and everything, right? So that gives us an advantage that those analysts have better understanding of supporting their verticals, but also being able to, know from each other what is the best way to get these reports out. So that way we can control some of the source of truth tables, but let them also build on top of these things more.
Actually, I'd also, the interesting question for the org of the size of DoorDash, what we typically see is that the roles within data organization also get more specialty. For example, there are analysts, there are data scientists, there are data engineers who are responsible for making data useful for those former two roles. So does it mean that every single role, even let's say data engineering, is also embedded? So let's say there's a product team working, I don't know, on maybe pricing, right? So would data engineer and analyst and data scientists all be embedded from their respective kind of vertical teams into that team?
So currently we do have a data science folks and analysts embedded within those teams. Data engineering is still evolving within our organization. Currently it's a bit centralized, but we may eventually, I mean, even though it is centralized as a team, there are dedicated individuals for each of these verticals within that team. And we do have a centralized data platform team that helps enable all of these teams. So that way the infrastructure and the needs that are fulfilled for various analysts and data science folks are centralized from the data platform perspective, but from the use perspective, they are decentralized here at DoorDash.
Cool. Gilbert, any thoughts on the team structure?
Yeah, my only thought is that having an analyst without a business use case is like using a technology just to use it without a business case. So I don't think any structure that removes embedded analysts is ever going to work. I've never seen that be successful. You always have to have some sort of embedded relationship with your product stakeholders. You always have to have a consulting client relationship, and I don't think any other type of relationship has ever been successful.
So related to that, I think originally when analytics was picking up maybe 10 years ago, the expectation was that data analysts or data scientists can do everything. So prepare the data for themselves, to analyze the data, publish it to stakeholders, maybe do machine learning. Then we saw the increasing specialization, but then it seems like we've also faced the bottleneck. So data engineers were responsible for making data useful for data analysts, who then in turn turned that data into narratives for stakeholders. And there seems to be never enough data engineers. And so what we seem to see now is with the development of tools like, for example, Narrator or dbt and other frameworks that kind of help build help lower the bar for doing data modeling, then the roles that are more hands-on with data seem to be self-empowering. So how does it work in your organization? Do you try to, do you expect every person who is supposed to sort of do the last mile data delivery, like build a dashboard, build machine learning model or report, to actually be able to do the data preparation themselves, or is it still something that a central team, central org responsible for?
So data delivery into the warehouse and data lake is being managed by the central team, but then how you use it is up to the analysts and the data science folks. And we also let them bring in more data sets into this pipeline by building a self-serve data platform pipelines. So we are enabling them to integrate more data sets, share it with external partners and ideas like that. But we do manage a standardized platform so that we are not going in 100 different directions.
Yeah, I'm not like a big fan of the wave that sort of believes that analytics does not need to code or does not need to touch the underlying rows and columns. I think like what Akshat said, having a standardized data platform like team that brings in like the data lake and sort of manages that, but then the analytics folks having being like the liaison between like what we need for the business and how do we actually get it through data is like very key. Like that is like I think one single benefit of having analytics folks and like being able to work with a business stakeholder because you're like that connector. So I'm very much a proponent of like analysts being able to script their own data sources because like that enables more for speed and accuracy. And it is sort of like a more rare skill set, I guess, to sit at the cross section of both business acumen and technical expertise.
I think it really depends on where you are as a business. I think if you work at a very small startup, the level of the types of different work you have to do as a data scientist, for example, really spans everything from like taking out the trash to building models and putting them in production. And that's great when you're like a 10, 15, 20 person company. But as you grow, like your control needs grow. And I've worked at very large companies before, particularly in finance, and there are a lot of benefits to those orgs to having more control and more division of labor and division of responsibilities. So I think it really depends upon who you are as a company, where you are in terms of your growth, and your needs are not needs for control.
Yeah, I think Gilbert brought up a really good point around the centralized need for centralization for certain aspects, because it helps bring compliance and security around and privacy kind of initiatives easier to manage for the company.
Awesome. Ahmed?
Oh, I was going to say that like at WeWork, we saw this thing transition left and right, like so many times. We would give everyone open-ended control to create the data model that they needed. And we were like, yeah, we're moving fast. And then every team, like I remember the CEO would bring me into the room and be like, these reports, who's right? Explain to me why everyone is claiming 20x increase when our sales haven't increased by this thing. Like, what the hell is going on here? And the central team is now going and debugging all their queries. And then we're like, no, we're going to control the data models and create bigger, more powerful data models. And what would happen is we would have every single team would just say blocked by data engineering, blocked by data engineering, blocked by data engineering. Because whoever controls the column rows that you have available and like how those things relate is going to control the questions you ask. Like these two kind of that dichotomy of trying to choose a balance between control and flexibility is literally what ended up driving me to be like, okay, I'm going to spend the next 5 years of my life trying to think of a data model that allows you to have control and that flexibility to do both so that the central team can maintain accuracy and reliability and speed while everyone is still able to ask and answer any question they need. Because you're going to see the organization shift their mind based on, we used to make this joke at WeWork where based on the columns, you can guess the questions that people will ask because they can only imagine the questions within the columns that we gave them. And once you start opening that up to be infinite, you'll see people start shifting into, wait, I never even thought about asking more of these questions. These questions are so annoying that I would never even bother asking. And we're seeing that shift, and that's kind of what excites me, to kind of figure out that balance and kind of trying to find a way to make it work.
Makes sense. So data prep, data modeling, structuring data and analytics is one thing, but obviously we can't be oblivious to the importance of machine learning, which is yet another world with its own infrastructure, its own roles, workflows, and challenges. So today we heard from Emeli talking about some of the fast ways that a machine learning pipeline can be monitored within the data science workflows, and also we heard from Gilbert, who presented the example of a streaming pipeline, machine learning pipeline in production. So I'm curious, as we are learning how to do data monitoring, data testing for like the data prep workflow, for someone who is starting with machine learning and maybe just get the model in production, what are the top 3 things they should think about when, in terms of monitoring quality, testing quality? What are the top 3 things that they should introduce as soon as they, or even before they ship the first model to prod? Emeli, Gilbert, machine learning experts.
Yeah, I mean, usually just getting it to prod is the end goal, right? You just take a couple days off, go away on vacation. No, I feel like I've only ever done this at startups, and we're usually in catch-up mode. So we're usually reactive with what we do after we get it to prod. But the observability piece is always the hardest piece that always seems to come up as a reactionary thing after the fact. So I think observability into drift, observability into why any particular prediction is what it is for business users, those are always challenges. I wouldn't say we've solved them especially well, but there are definitely challenges that come up that we want to address.
I agree there, and maybe because I have more engineering background, I would say that it's very important to understand that when you move your machine learning model in production, it's production service, and it makes sense to start with the all standard service health monitoring that we apply to any other services. And you cannot just like take your model, put it into Docker and start using it, right? So you need to use all this infrastructure, use your Prometheus database, Zabbix or Grafana or whatever is used in your organization, and apply it to your machine learning model. You might need to start logging more, I mean more events, more metrics, but all the other infrastructure should be used there. And maybe a third thing I believe makes sense is to start thinking in advance about the actions you can take after you see some specific values of metrics or get some alarms, because, well, there are frankly a lot of different quality metrics that we can calculate, right? So a lot of drifts and things like that. And when you, for example, have like hundreds of features and you see that one particular feature is drifting, what are you going to do, right? So are you going to retrain your model or just ignore that? So it makes sense to think in advance how are you going to react, and only after that set up some alarms and monitoring architecture, let's say.
Yeah,
So it
Yeah,
sounds like
monitoring is super important. Like hire ML ops engineers. Just as an aside, to piggyback on that statement. Yeah, hire some people who know how to do that stuff.
Yeah. Also, on top of monitoring, I used to do AI for missile defense for the U.S. government, and deploying those algorithms to production is a lot more on how do you make sure that this thing doesn't fuck up. One of the things that they make you do there, which is a good practice when you're pushing anything to be like tactical, is to define the exact assumptions you make by the model and have a separate system that checks to see, is the assumptions I made in this model still consistent? Like till today, I still interview machine learning engineers and ask them like, you know how to do a best fit line? And they're like, yeah. And I'm like, okay, tell me how to do a best fit line where no error is negative. And you'll see that most people ignore the assumptions that are made when we do these models. And you can see once they start thinking about the assumptions made, they realize that, okay, this model works in these 17 specific conditions, and once any of them break, this model is going to behave very differently than expected. And making sure that we are write down those assumptions, I think, can really help with monitoring, to help kind of narrow down what we monitor, like Emily kind of mentioned with her shift in the user base.
Awesome. Well, I'd love to continue this this panel, but we are a few minutes over time. So I would like to conclude with saying huge thanks to Emily, Gilbert, Katya, Akshat, and Ahmed for joining us today, giving amazing lightning talks and sharing your thoughts on the panel. Data Quality Meetup is an event we are hosting for our community to help disseminate the knowledge and for everyone to find the ways to what we call do data better, whatever it means, not necessarily with regard to the quality of your columns and tables. So for everyone who is listening in, we'll be distributing the recording and the digest of the event. If you want to get in touch with the speakers, we'll also publish the best ways to get in contact with them. And with that, wish everyone great rest of their day or good night, depending on where you're dialing from. And see you for the next meetup. Bye.